Hello, everyone. My name is Iosif Itkin. Welcome to Exactpro FinTech webinar. Thanks a lot for joining. We'll start in a minute. Okay. Once again, hello, everyone. My name is Iosif Itkin. I work in Exactpro, and this is FinTech webinar dedicated to fixed protocol that is used in global exchanges division. Head of global exchanges division in Exactpro is organizing a training course mainly for Exactpro people, but it is also open to external parties. And she kindly allowed me to talk about fixed trading community and fixed protocol. Thanks a lot for watching this stream. You're currently on Exactpro YouTube channel. We have lots of videos here dedicated to FinTech, software testing, software development, etc. We recently uploaded a new course about autonomous vehicles and intelligent complex systems. Please have a look. If you are watching this stream or video, please help us to promote this content, subscribe, share, and press the like button. Thank you. So what these destinations have in common? It is not food. It is not a drink. It is a protocol, fixed trading protocol. Fixed trading protocol is used across all these locations. So these are locations where Exactpro's global exchange team works with regular and crypto exchanges, where we deploy our platforms, apply our processes, and use our people to work with complex, mission-critical trading infrastructures. Exchanges and clearinghouses from Sydney to Toronto, from Johannesburg to London are using fixed protocol. It is very common across trading industry, and that's why it might be useful for you to learn more about this interesting technology. I think I have a better and more energetic video describing the fixed protocol. Let's have a look.
Equals D, 55 equals IBM, 40 equals 2, 44 equals 20. I'm going to give you the fixed protocol. 35 equals D, 55 equals IBM, 40 equals 2, 44 equals 22.5, 59 equals 0, 50 equals Carlisle, 49 equals my firm, tag equals value. The fixed protocol is just an electronic language used to communicate orders between different parties on Wall Street. It's as simple as that. The fixed protocol.
Okay, I think it is much better than anything I can accomplish with this stream. But anyway, let's proceed. So there are several types of trading systems. In general, we can split them in three: buy side, sell side, and exchanges. So buy side are the companies that are using financial services provided by other companies to submit their orders. This can be proprietary trading, high frequency traders, various funds, etc. They use sell side brokers to submit their orders. Brokers process their orders and send them to exchange. All three types of entities rely on servers. You can see servers underneath each of the pictures. It means that not just future, but today everything is happening over electronic protocols. So computers talk to computers most of the time. And in order to do so, they need some protocol or API for communication. If you are interested to learn more about APIs and what are they and what are protocols, please refer to lecture 3 of our software testing for complex intelligent systems and autonomous vehicles course. Okay, so let's have a look. The slide contains a link to research paper from Exactpro team, reconciliation testing aspects of trading system software failures. It was presented several years ago at Sarkozy conference for young researchers, and it is dedicated to Knight Capital runaway algo. It is something like 45 equals 450 millions. So within 45 minutes, a trading algo lost $450 million. And this research paper contains description with references to SEC investigation. I took a liberty to take a diagram from there. Here it is. So we have three types of systems present on the slide. So we have buy side clients. They are submitting their orders into the system. Then there is Knight Capital, who in this particular case, they were sell side. They were responsible for taking clients' orders and routing them to markets. And then there is the third part, markets themselves. So we have all three types of systems present on this slide: buy side, sell side, and exchanges. A client sends an order. Here it is parent order. Then order management system within sell side uh, decides what to do with the order and produces child orders that are sent to markets, to different exchanges. So where we can have fixed protocol in this situation, we can have fixed protocol for communication between clients and brokers. It is the one on the left on top of parent orders, or we can have it for communication between brokers and exchanges. So it is the one on the right on top of child orders. Okay. Uh, if you are watching this stream, it's very likely that you are working in Exactpro. Most of our work is concentrated on the third type of trading systems, exchanges. On this slide, you can see probably familiar reference architecture for the stock exchange. Now let's try to find fixed protocol on this slide. Here it is. So exchanges use fixed protocol at least in three different areas. These three areas are pre-trade, trade, and post-trade. So pre-trade allows clients, brokers to receive information or do preliminary research before submitting orders. Trade is when the order is submitted into exchange and processed by the matching engine. And post-trade is allocating trades, confirming, creating positions, collateral management, etc. So if we look at the slide, we have pre-trade, receiving market data from the system. Not all exchanges, I would say most of exchanges are not using fixed or fast protocols for market data, but there are some that do. Then it is this one in the lower left corner. We receive market data from market data gateways. Then the main application of the fixed trading protocol is in trading, where market participants submit orders and receive execution reports over fixed protocol. So it is at the top trading. And then we also have post-trade. It is when exchange is communicating with the post-trade infrastructure. For example, deliver information about executed trades to central counterparty. In many cases, in our work, it is implemented using fixed protocol. So these are three main applications of the fixed protocol. Fixed protocol appeared somewhere in 1994, and it is currently maintained by the fixed trading community. Next video describes what one can do with their website. Let's have a look. One can open the website. Look into the working groups, and also open materials relevant to our work, including the tool that supports Fix Protocol TH2 and other interesting videos and materials. Okay, so this is fixtrading.org. Fixed Trading is a global organization, and quite a lot of companies are involved in developing and promoting fixed trading protocols. So there are 24 global premier members, and there are also 247 members of the fixed trading community. So even if you do not work in Exactpro, there is high degree of probability that your company, if it is a bank or exchange or technology vendor, that it is also a part of fixed trading community. This slide shows 39 members who are exchanges from Australia to Tokyo, from Nasdaq to Euronext, and some of them are members several times in Switzerland, in US, everywhere. So everyone is using fixed protocol, including exchanges. So there are at least 39 members who are using fixed protocol and actively participating in the process. So what you need to do if your current company is a member of fixed trading community, you can go to fixed trading community website, press register, and create account and specify name of the fixed affiliated member firm. And you'll be able to access all materials that are currently present on fixed trading community website. There are many interesting working groups on the fixed trading community website, including those dedicated to digital assets, cybersecurity, regulations, etc. One of the working groups is monitoring, onboarding, and software testing. It is very relevant to the things that we do in Exactpro. So fixed trading protocol, if we put it across protocol models, TCP/IP model or OSI model. In TCP/IP model, it stands for the application layer. In OSI model, it stands for three layers: session level, presentation layer, and application layer. So fixed technical standards. The diagram on the slide shows the family of fixed technical standards and also the distribution across different layers. So the session layer is responsible for maintaining connectivity in the sense that it is responsible for logins, logouts, sending heartbeats, etc. Encoding part is responsible for encoding messages. And currently, fixed technical standards allow different ways of encoding messages, including tag value, the one that was referred previously in 54 equals D, etc. We'll talk about it a little bit more. There are other encoding standards with various focuses to compress traffic like fast, to make communication faster like simple binary encoding, etc. And application layer are the messages themselves, the messages that are sent between different computers, different robots to communicate between the trading parties. So this is a screenshot from Big Trading Community website. It shows various links to different technical standards. Going back to the basics. So computers, when they are involved in trading process, they communicate through messages sent over API. It can be fixed, it can be other interfaces. And they need to deliver certain information to each other. For example, if one computer is trying to request a trade, so it is sending an order, and order has various attributes. For example, side, it can be buy or sell. So whether we are trying to buy securities or other financial instrument or sell. It can contain price, it can contain order type, market limit, it can contain time and force, the validity of the order. And of course, it can contain and should contain quantity. How many shares are we trying to acquire, or how many shares are we trying to sell? So these are attributes for the order message. And when a broker or exchange gets the order, it is trying to process it and replies with the message. The message is execution report. It also has many attributes. These attributes can be symbol representing security, order status, whether it is accepted, rejected, filled, part filled, pending, etc. Order ID is ID assigned by exchange or broker. Executed quantity, it is the part of the order that was executed already, etc. So all of these are message attributes. One second. Message attributes can be represented as a table or a dictionary where we have a list of pairs, tag and value, or field and value. For example, tag or field message type. So there can be different types of messages. new order, order cancellation, order amendment, etc. Site, another field, can be buy or sell, etc. So these are examples of the messages that can be used. It is possible to encode them in different formats. So one can optimize it and use some binary form. One can use XML, JSON, CSV, etc. But almost everything can be represented as a dictionary in the script languages or in Excel, etc. There is one notable exception. It is when there are many similar things. For example, if we describe the pressure in each of the cars, sorry. So if we describe some parameter and the message that we send have multitude of these parameters or parts. For example, if we are sending some message that is required not to submit one thing, but many things. Or if we need to submit not a single party, but multiple parties. And in this notable exception, it is more difficult to present such messages as a simple dictionary. And that's why there is a separate approach called repeating groups that we probably will not cover in this particular session. So it is possible to encode dictionary using several different formats. For example, one can convert it into a string of separated tag values pairs. So we can put message type equals new order, a separator, and symbol equals Fox24, etc. What fixed protocol does, it assigns a tag number to a set of standard fields. For example, message type field has tag number 35 and symbol has tag number 55. So it is possible to make the message shorter and more computer-like, I would say. It is one thing. And another thing that there are several types of values. And one of the most common type of values for the fields in protocols is enum type. It is when there are several different possibilities for a field. For example, for the message type, it can be new order, execution report, log on, log out, and some more. But the number of the selection of message types is limited. So we can use a shorter values to represent different types. The same goes to order type. So there are different types of orders: market, limit, stop limit, etc. And instead of using the full name, we can use a set of values. For example, 1 goes for market, 2 goes for limit, etc. buy and sell orders. 1 stands for buy, 2 stands for sell. Time and force, once again, orders that are good for today, time and force equals 0. Orders that are good until cancellation, time and force equals 1. Orders that are fill or kill, time and force equals 4. And this is how we structure the messages. So message type equals new order single stands for 35 equals D, 55 equals Fox 24, 54 equals 1, etc. So this is a shorter and more convenient format for computers. It can be implemented across a number of languages. 1 second, sorry. Across a set of different platforms, a set of different languages, because it is a network protocol that describes what is required, and there is no need to have particular library from particular vendor to implement it. You can go and implement it in Java, Kotlin, C#, Python, any programming language. Let's go next. There are additional important parts of fixed messages. They are standard header and standard trailer. So what we send in the beginning of the message and what we send at the end of the message. Parts of the header are sender comp ID and target comp ID. They represent the sending party and target party, and they are used for routing messages most of the time. There is also a method to maintaining the sequence of the messages to check if there were any gaps during disconnects or any problems on either side of communication between the trading parties, and it is implemented using tag message sequence number. We'll probably cover it in a separate session dedicated to fix connectivity and maintaining sessions, heartbeats, etc. There is also a checksum tag that is used to validate that the message is not malformed. Okay, this one shows the message new order single on top, execution report at the bottom, and the binary representation. For the separator between tag value pairs, a symbol with ASCII code 1 is used. So we constantly have 0, 1 inside the message to split. And 3D is equals sign. So you can see that there are many 3Ds, and there are also 0, 1. So this is how fixed messages are encoded. So there are different types of values. Previously, I've presented a slide that contained value type enum value type where a particular field can have a limited number of values. But there are other types of fields. For example, sequence numbers are integers. Prices can be float. For example, it can be 137.36 or something like that. Account names, sender comp IDs can be strings, etc. In some cases, there are limitations for the size of the fields, for the format of the fields. Sometimes they are clearly defined, sometimes they not. You can go to the fixed trading community website and find a tool called Fiximate, and it allows to get description for every message and every tag present in the standard. Also, Fix is more than 20 years old, so there are different versions of Fix protocol. You can have a look at specifics for different versions. And you can also look at different field types. They are also present in the tool. On fixedtrading.org, there are many interesting materials, especially in a section called beginners resources. There are some documents like in PowerPoint from 1996. Unfortunately, my Microsoft PowerPoint was not able to open this document. Probably it is too historical, but other documents are there, and some of them are still relevant. Even I would say most of them are relevant. For example, fixed technical background from June 2000. It contains description of session layer, application layer, and the structure of fixed trading protocol. So Fix is used by the most modern exchanges and brokerages across the world in very sophisticated modern systems working at sub millisecond within hundreds of microsecond latencies, but its origins go back to 20 years ago. So you can go back on the memory lane and have a look at this historical artifacts. There are more recent documents also available. In particular, you can download, if you are registered on Fixed Trading Community website, you can download a simple document that describes tag value encoding used in Fix protocol. It is just 25 pages, and it is a fascinating reading. Different exchanges may use additional tags that are not defined in the standard fixed protocol. Also, they may require some tags and may not require some other tags. That is why it is very important to look at fixed specification belonging to particular broker or a stock exchange. We have a project that collects all fixed specifications because we would like to pass them through our NLP software to identify any problems, ambiguities, etc. So almost every exchange in the world, many crypto exchanges, etc., have fixed connectivity documented and available online, and that can be accessed. For example, this is a simple option, fixed specification from a broker, Exante. You can see that new order single message, the message where we submit a new order, consists of standard message header, standard message trailer, and a small number of tags. Most of them are not required. So this is a simple option. And this is a more sophisticated option where we have more than 20 different tags, including something like 2710 passive only order or routing in 9303. So fixed trading community allows a certain number of custom tags, and it also allows exchanges, brokers to add additional tags that are not standard without registering them. You can find more information on fixed trading community website about user-defined fields. So all tags from 5,000 to 9,999 are already occupied, but there is still some room left to add additional interesting and sophisticated tags. So there are benefits and drawbacks in using fixed protocol. We can probably cover it in more details during another session. Fixed protocol, the main benefit is that it is standard. So standard in terms of protocols. So its actual implementation and list of fields differs from exchange to exchange, from broker to broker, but the encoding itself is standard. So when somebody is trying to implement a new trading system, it is easier for them to do it. Fixed protocol is quite simple and clear. It contains all the necessary information. It is customizable. It is possible to add new fields and values without modifying your software, rewriting the code completely. The length of the fields is not fixed, and it is possible to omit tags, etc. There are drawbacks. So here it says that big size of the message comparing to what? There are more efficient ways of encoding message, but there are also less efficient ways. So you can send XMLs, you can use names of fields instead of tags, etc. So there are faster and more efficient ways to encode trading messages on one side, but there are also less efficient ways. For any particular exchange, there are too many unused fields. Well, We are talking about thousands of tags and values, and you can see that in even in large fixed messages there are only several dozens. Um, the length of fields message is not fixed. It can be a benefit, it can be a problem, and there are multiple possibilities to send something wrong. Yes, so there are many things that you can do wrong with fix. What we have not covered today, we haven't covered the main thing that specifications exist in two different forms or a combined form in machine readable and human readable. There is a dedicated project within fixed trading community to improve machine readable specifications. It is called Fix Orchestra. I hope we'll cover it at some later date. This session also omitted information on headers and trailers. So how what they contain and how to encode them. About repeating groups used in many exchanges, especially in derivatives ones where there are many legs for particular uh, orders. Administrative messages and session level communication, so logins, logouts, heartbeats, resend request, etc. And also in this session, we do not cover monitoring, onboarding, and software testing for fixed trading protocol because each of these three topics deserves a separate consideration. Thank you very much. That is it for today. Let me check if there are any questions. Thank you. There are no questions. So let's wait for a minute or so. So this presentation is the part of Global Exchanges introductory course for Exactpro team. It can be used also by anyone else who is working in FinTech with complex trading platforms. We intend to release more lectures to be publicly available, and the next lectures will cover exchange architecture, defects, submission process, and market data using model-based testing, etc. So we intend to include into this introductory course quite a lot of information relevant to software testing and development of the modern exchange platforms, including crypto exchanges. And there are no questions. Thank you. Thank you very much. So we are closing this sessions, and I hope Alona will allow me to speak at some other occasion. If not, there are other interesting speakers as well. Thank you. Thank you very much. I think we can stop the stream now.